Hi, in this video, I'll brief you about advanced EV powertrain setup. The setup is developed by Decibels Lab for the purpose of creating practical and hands-on learning activities about electric vehicle. To make this happen, we have the complete setup where we have all the vehicle components on the bench. So we can say a vehicle on bench. In extension to that, we also have added more components so that we can really see and visualize what is actually happening when the vehicle is running on the road, and also introduce a lot of faults and diagnostics and other activities in place. To give you a quick idea and understanding, the first and primary activity of this setup is to give an idea of what are the components of an electric vehicle, then how the components are integrated together to make a complete system as an electric vehicle, then to study and induce some faults and understanding the diagnostics of an electric vehicle and its components. Apart from it, we also have CAN communication protocol so that we can study the battery management system CAN and also the motor controller CAN, where we also have the smart BMS in the battery pack. We can configure the BMS and vary the parameters and study the behavior with respect to those parameter changes. Then you get a software to access the BMS so that we will be able to visualize what actually happening with respect to cell voltage, current, fault parameters, and any other threshold activities which are happening inside the BMS for the monitoring, protection, and operations in place for the estimation of SOC and SOH activities. In addition to that, as we have a smart motor controller, you get an access to configure the motor controller parameters and get to visualize the motor controller software and inside activities of the motor controller software as well. In extension to this, as I said you that we wanted to make this setup so that it creates the real-time driving of the vehicle in place. When you're driving the vehicle, that means you're applying the load on the motor, and the other conditions, the motor is also acting as a regenerative system as well. To make this happen, so we have two motors on the sides and then we have a load. When you want to recreate to see how the load is applied on the motor or a traction motor, we have a setup where we can apply a load like a rope brake load, and then in that way the motor is subjected to a load conditions. So you can see how really the motor is drawing the current and also how the phase voltages or phase currents are changing. And then on the other side where the DC load is being applied on the battery pack as well. When you perform the regenerative side, at that time, the motor on this side, which is in the back end, will act as a motor, and this component will act as a regenerative part. So that the regenerative current that is produced from the traction motor will be fed back to the motor controller, and then it converted into DC and then fed back into a battery. So you can observe all of these parameters inside the complete test setup. Which I mean to tell you is that you get to know the whole vehicle and its behavior within the complete test setup. To make this learning activity much more understandable and fluidic, we also have developed about 7 experimental activities. As a part of all of the 7 experimental activities, where you really conduct the experiments and then study how the whole system can be broken down into a specific subsystems level activities of the experiments and then conduct them in a real time as well. To make this happen, if you give you a quick simple example with one of the experiments, when I talk about Precharge setup, right? So you know in a vehicle there is a Precharge activities, right? What do happen in a Precharge? Because there are DC link capacitors inside a motor controller. When you turn on the key, they can suddenly get charged because of an inrush current. And those capacitors create their inrush current, and this can damage the battery, the fuses, and the motor controller itself. So how does the precharge happen inside any cars or any trucks or buses, for an example? For that, we have a set of components that will really make this happen. So to demonstrate this, we have an experimental activity where we can really see if you do not enable the precharge and directly pass the output of the battery to a motor controller, you can suddenly see the voltage rise within a milliseconds. But when you induce a precharge through a set of switches that we have given here, a learner will really understand how does the precharge happen through a specific sequence, which is precharge resistor, which is main contactor, and which is the precharge contactor, which one to enable first, which one to disable first, and then how do you see the voltage rise across the motor controller. Also, when you shut down the system, how does the active discharge also can happen, can be studied, or a passive discharge can happen, also can be studied through the test setup as well. In this way, there are a lot of activities that will enable a learner through a several set of experiments so that you really understand in a more practical way and a hands-on way within the test setup to get to know an EV in a much practical and a hands-on and an in-depth way. With this setup, you can enable your learners to make the learning journey much more playful and much more engageable with a test setup in place. So if you're looking forward to enable your students, this is a test setup for you to take forward for it. Thank you.